Yep. Sure then. Okay, so let us begin. Okay. Okay, guys. So let us begin the new concept for today. And so let me tell you what happened in the last class. In the last class, we were discussing about electromagnetic waves, right? So what are those waves? What kind are they? How do they travel from one point to other point? And what is their energy? So we discussed many aspects of electromagnetic radiation and their uses also. And today we are going to discuss about communication system. Okay. So for example, let me take a very simple example, and let me take a very well-known example. Okay, so conducting online classes, right? Very simple. So that's we're all familiar with. So that's a part of communication. I'm talking to you, you talk to me. That's communication, right? So essentially, what does communication mean? Communication means transfer of information. It is transfer of information from one person to another person, from one point to other point, and that's right exactly what's happening right now also, right? So for example, let me take myself here. So I'm sitting in my home taking online classes. So there are my audio waves. Okay, rightly they're going to the microphone, my earphones. There the earphones are connected to electrical signals, right? And they travel to my laptop, right? And from my laptop, they there's the internet services, and from the internet services they travel to the nearest tower, and they propagate and they reach your mobile phones, right? They reach one more tower near you, and from that tower they reach your phone as electromagnetic radiation again, right? And as after that electromagnetic radiation is again converted into audio and video signal. So this is what is basically happening in all the online classes, and this is the modern communication. This is the modern communication, right? So we are going to see and understand how this happens in a much more detailed way. I was just very crude here, but we'll try to understand how this happens in a detailed way. Okay, how was electric audio signal converted into electrical signal? How electrical signal was transmitted as a radio wave? Uh, all this interconversion and how to send them, will they get absorbed in between by the walls, trees, buildings, and how to encounter them, how do we use satellites for this motion? We are going to see all of them today. Okay, so let me divide this class into three parts. Okay, so part 1, part 2, and part 3. So part 1 gives me information about what are the basic components. So basic components of communication system. For example, what's a mic, what's a transducer, what's a terminology here. So they are the basic components. Okay. After learning what are the basic components, we'll understand how to send waves from one point to another point. So there is basically ground waves, sky waves, and space waves. So we'll see there are these three kinds of waves, and what are they? We see. Okay. And later on, we'll see something about modulation. Modulation. You know FM radio, right? Can any one of you tell what is FM? Can any one of you expand what is FM? F and M. Any idea here? Frequency modulated. Very good, Lavi. Yeah. So they are frequency modulated, right? So we are going to see what is frequency and what is modulation. Okay. Cool then. So we are going to discuss a few topics today about all of this. Okay, no issues. And coming back to the concept. So okay, cool, right? Is everybody cool here? Everybody fine, comfortable, right? Yeah. So let us begin without any further delay. And what's going to happen is very simple. Okay. So yeah, in ancient times, in very ancient times, how should we communicate? How were we communicating? So if you remember, we use pigeons. You might have seen in old movies, right? So there's a king who wants to send a message to another king, or his girlfriend. So what does he do? He takes a pigeon, right, and he does tie a message to that pigeon, and he sends it far away. That pigeon will be carrying the message from one point to other point. Very simple. So similarly, from ancient time, we were using smoke to communicate danger. If there is any problem in my kingdom, I put a very huge fire, and that will be communicated from this point to that point. KGF. There are a lot of the rings, and also in KGF, right? Um, he uses fire to communicate from one point to other point, right? So that's one way. And drums, and like so whenever people are happy, they used to beat drums saying that like we are happy, right? Or when there is some animal attack from one place, you could use drums and communicate to other people. How to scare animals, you can use drums. So that's one way of communicating. And another is flags. So this was recent, quite recent, like from 500 600 years we're using flags to communicate victory or surrender, right? So these are the old, very ancient times. And recently after this, now the communication is a bit evolved, and we have started use telegram. Okay, in around the 17th century, 16th century, we used to use telegram. Later on, Graham Bell invented telephone, wire telephone. Then we had wireless telegram. Using electromagnetic radiation, we started using wireless telegram. Both of these have wires, okay? But here, it's a wireless telegram. Later on, we had again a television, right? So which was one of some very famous and popular way of communication. So and now we have internet, wireless phones, mobiles, right? So we have very well developed in the modern communication system. And the modern communication, what we are using right now, you'll study when you go to electronics and communication, or electrical engineer, or computer science. When you go to that branch of engineering, you'll study till then. But our objective today is to understand the basic and old communication, which we don't use anymore. Right? Nobody uses this. Who does use telegram? No, nobody uses telephone. Nobody uses telegram. We use phone. We use, uh, you know, laptops, email, right? And I hope nobody watches TV also. Like all of them has their phone of their own, and yeah, that's fine, not a problem. Okay, so they are the oldest way of communication. And coming back to the new way of communication, okay, and as a process, if I tell you what is communication and what does it involve, so it involves basic steps. Okay, so let me write them down. Make sure you understand it. There's no need to bahut it. You have to understand it. Okay, so when a person speak, if you want to talk from one place to other place, one place to other place, how does it move? So what are the ways of communication? Let me tell you. So there is person A who is trying to speak. So when the person A speaks, audio waves, right? Audio waves are generated from his or her mouth. They travel, okay, and they reach a phone or a microphone or something like that. And that microphone, we have something called as transducer. We have something called as transducer. This converts one form of energy to other form. For example, to be more accurate, one form of signal to other form. So if we have audio signal here, so this transducer will convert audio signal to electronic signal. So in my earphone or microphone, the waves won't travel, audio waves won't travel, rather than electric waves travel, right? So transducer converts audio signal to electronic signal. Completely fine. Then that signal will reach my laptop. It will process. Okay, it will make some modulation, or we'll see what is the processes and what does it do. We'll see. And my electronic processor is laptop here. He does some processes and it'll transmit. Okay, it will send out the signal to the nearest tower, and the process of sending out signal is called as transmission to all location. Okay, to you. If you want to receive a signal from my place to your place, you need to the signal to travel, right? So that is called as transmission. It's calling the start sending of signal. This is start of communication system, and the signal will travel in the form of electromagnetic radiation from one point, and it will travel very long distance, and it will reach you. You are the receiver, right? It reaches your phone. Then after it reaches your phone, what happens? Again, there's a transducer. It will convert this electrical signal into audio signal. So you're hearing my audio, right? You are able to hear my voice, not the electrical signal. So again, there is one more transducer here, which will convert that received electrical signal into audio signal, and it goes back to ear of person B. So this is the basic sketch, or they might ask you to draw the diagram also. What's the block diagram of communication system? They might ask you in board exams. So then you need to draw this or write this sketch. Okay, cool, right? So we'll come back to this diagram. But before that, let me explain you what the transducer is, what is the receiver, what's the transmitter in much more detailed way. So when I explain that in a much more detailed way, I'll come back and I'll explain you that same diagram again. So we'll go step by step. Cool, right? So am I clear, guys? Is this fine? Uh, if I'm fast, you can ask me to go slower. Okay. This is like a chapter which is a story. There is not much physics concepts to remember. If you feel I'm fast, YouTube guys or Zoom guys, you can let me know, sir. Slow down, or you can let me know. Okay, not a problem. And it's very simple. Chapter is very simple. Cool. And before I go to transducer signals, let me tell you how do we communicate? What are the different modes of communication? Okay, so we have two different kinds of communication. One is, for example, I take a phone and I'll call you. I'm calling person to person, right? So person to person communication is called as point to point communication that happens between one person to another person only. Okay. For example, if I send an email, I'll send my email to you. So that's person to person communication. From one person to one person is called as point to point communication. Later on, we have something called as broadcast. So what's a broadcast? A broadcast is one person to many person. Okay, so what's happening in online class is the same thing. I'm a single person who is talking to many of you, so that's a broadcast. Okay, so I hope you're clear with what is a point to point communication and what's a broadcast. So let me give you much more idea here. So for example, here one person in India wants to talk to a person in USA. Okay, so they contact along phone or email, and that is called point to point communication. So one person in India wants to talk to a person in USA. Okay, so that is called point to point communication. Okay, sorry for the trouble there. I'm back. Okay, so uh, I don't know. There's a problem in communication system, I suppose. Yeah. Okay, so we are back anyhow. Okay, so let me wait for the YouTube to respond. If I'm clear with the YouTube, we'll begin. Okay, and thank you for waiting. Really good. Okay, thank guys. Okay, so coming back here. So let me explain what a transducer is. Okay, so what's a transducer is? So what is a transducer? So I hope am I clear, guys? Come on, click on yes or no. If you're clear with what is point-to-point communication and what is broadcast communication, am I clear with those two things? If I'm clear, click on yes. Yeah, so I need you to respond, guys. Come on. Yeah. Okay. Cool then. YouTube guys, am I clear? I hope I'm clear, right? Okay. So let us come back to the transducer then. if I'm clear. So let me revise very quickly. A point-to-point communication is a person-to-person communication, and a broadcast communication is a person-to-many-person communication is called as broadcasting. And coming back to transducer, so you will understand the basic elements of the communication system, and one of it is transducer. Okay, what is a transducer? As I already told you, it converts one form of signal or one form of energy to another form. Okay, for example, it will convert audio sound waves, audio signals to electrical signal. So this is what it does do. Okay, we'll not go to the construction of transducer. It's left for engineers to understand it. But I'm just telling you that there is this kind of an instrument called transducer in our microphone or in a telephone. It's basically everywhere, and this can convert one form of energy to other form of energy. That's all, very simple. And so let me explain that with the help of a block diagram. So here there's a person and he's holding a mic, and there is a speaker here. Okay, there's a speaker here and there's a mic here, microphone also, right? So what's happening here is this microphone, okay, is taking the signal and it's transmitting. Right, this microphone will take my signal and it will send out the signal. So it is called as a transmitter, and this will receive the signal. And both in transmitter and receiver, I have transducer. Why do I have transducer? In the first place, my audio signals which are coming out from the mouth are converted to electrical signal right inside the wire. The wire has electrical signal. So from sound signal to electrical signal, conversion is done with the help of a transducer. Okay, similarly, when this electrical signal reaches the receiver, whenever it reaches the speaker, so what does it do? It basically again takes my electrical signal and it will convert to sound waves or audio signals. Right, so again, we are going to use transducer in between. Cool, right? Am I clear, guys? Yeah, I hope I'm clear. Okay, sure. Okay, so this is a transducer. Very basic. Remember those things. If they ask you in board exam, they might ask you, then answer it. But there is a high probability that they won't ask this in JE. I'll tell you what will be coming in JE in a later moment. Okay. So signal. So what is a signal? You might ask me, right? So signal is very simple. Signal is nothing but a information. Okay, for example, electrical signal or audio signal, it's nothing but an information. Okay, so information converted from in the form of electrical signal is called as I mean, if information is converted to electrical signal, then we call that electrical form as signal. Okay, so signal is what carries information. So this is carries information, and usually we use electrical part as, we don't call audio as a signal, we call electrical wave as a signal wave. Okay, and a signal is one which is very good for sending out and receiving. Okay, it's very good to send out a signal, it is very good to receive the signal. Okay, so it's a form of uh, energy which is very good to transfer and receive. Okay, that is called as a signal. Okay, for example, here when I'm speaking, right, when I'm speaking, I was here I had audio waves, and when I'm hearing it, there was audio waves, but the signal here is electrical signal. Okay, so voice was converted to electrical signal. See, you can see this, right? So this was how the current was moving inside the wire, and this is called as electrical signal. Okay, cool, right? Yeah. Oh, okay, great, awesome. So, and there are two types of signal. The first signal is analog signal. The second type is called as a digital signal. So, what is the analog signal? For example, if there is a continuous disturbance, like a sine wave, it is called an analog signal. If the electricity or the electrical signal is varying like this, it's called analog signal. If I have only like this breakdown, a positive and negative value, only if I have binary values, if I have any two binary values, if the signal is varying in this particular way, then I'll call this as digital signal. Okay, it has either 0 or 1 output. For example, computer, digital, it works on 0 or 1, right? So this becomes 0, this becomes 1. If there is only 1 and 0 as output and input, it's called as a digital signal. If there is like 1, 1.5, 2, 2.5, all those values are there, then it is called as an audio signal. Okay, yeah. So coming back here, as I told you, if there are continuous variation, it's called as analogous. If there is only discrete values like 0 and 1, very specific values, discrete means specific. So if there are only specific values, then we call it as digital signal. Okay, and here I have an example for you. See, this green signal is varying continuously. It is going right from point to point. It is varying from every individual value. So it is a continuous signal. It is varying continuously. But whether you see the blue line, either it is at the top or it is at the bottom. Okay, it doesn't stay in between. See, once it is at the top, it come back to down. From down, it goes to top. So this blue here is called a digital signal because it is only having the upper value and the lower value. But if you see the green, it takes all the value in between. Right. So these are the examples. Okay. A sine wave is an analog signal. A square wave, a square shaped wave is a digital signal. Okay. Cool. Right. So we have learned what's a transducer, convert from one form to another form. What is a signal? It's a very thing which carries the information under two types of signal, analog and digital. Okay. Yeah. And we'll come back to noise. So have you ever noticed if you take your phone near the TV will have like some noise or disturbance, or when you're in a call, and if you take the TV towards the call, it might behave differently. So there is something called noise. Noise is an unwanted signal. Okay, some disturbance due to network issue, that may be also noise, or some disturbance due to some other extra signal is called as a noise. Okay, any unwanted signal that will change my information, which change my signal, is called a noise. Okay, so for example, let me show you. Initially, I had very good signal. My signal was very proper. It was very clear. But suddenly, from somewhere, some electrical, some other signal, there comes a disturbance, and it's called as noise. See, you can very clearly see that this noise combined with my signal has distorted, right? This noise is disturbing my signal and it's converting into different form. This is now I'm not audible, you are not audible clearly to me, or I may be not audible clearly to you, right? So noise is something which is going to disturb the actual signal. Okay, it will disturb very badly. Okay, and we have to remove the signal. If I want you to hear me clearly, I have to remove this signal, right? Yeah. For example, imagine in a bunch of class where there's a bunch of students, a teacher is talking to you, some other two students talking in the back desk will disturb you, right? So they can be thought as a noise, which is not desirable, right? We don't want them to talk. We want to listen to the class, but their speaking will become a noise. Okay, and we can remove the noise. Like we can make those two people to shut their mouth, right? Similarly, we can remove the noise by using some electrical devices. Okay, am I clear with these concepts? Okay. And transmitter. So what's a transmitter? So transmitter is a device or an instrument which will send out the signal from one point to other point. It transmits. Okay, it transmits. So the process of transmission is called as sending the signal. Okay, sending the signal. For example, if I take a bunch of food and if I light it on fire, that's a transmission. I'm sending the message, right? So that is called transmitter. Okay. And the best transmitter which we see is are the towers, the Geo tower or the Airtel tower. They transmit signal from that particular point to different places. So if I'm calling a person, the signal will reach the nearest Geo tower or the Airtel tower, and they transmit the signal from this point to other places, other countries, maybe other states also. So this is a transmitting device. Okay. And similarly, if you have a transmitting device, we of course will have a receiving device, and that receiving device called as a receiver. Okay, so this will accept the signal. So we initially send out the signal, and receiver will accept the signal. Okay, here I was sending my input. So in transmitter, I was sending my input. Okay, the input is being transmitted from this point, and it is getting transmitted. It's being sent everywhere. Now I'm receiving that input, and this receiver will convert that input into output. Okay, so basically, again, a tower which will catch the signal is called a receiver. See, signal is coming from another tower, and this tower is catching that signal, and this will send the output. So input is coming here, and this will send the output to me. Right? So that's the work of it, receiver. So receiver is a very simple object. It accepts the signal and gives me the output. Okay, cool, right? Okay. And imagine if the distance between the transmitter and the receiver is very, very far. If they're like one is in Bangalore, other is in Mangalore. You imagine they're such far distances. The signal will become weak while it is traveling, right? And that weakening of signal, that loss of strength of signal is called as attenuation. So attenuation is nothing but loss of signal. When signal loses its strength from while traveling from one point to other point through air or through water. So that is called as attenuation. For example, see here, my initial strength was very strong, but now what had happened? The signal is traveling and becomes weaker and weaker, and when it reaches me, I have only very small amount of signal. right? And this is attenuated signal. The signal has lost its strength, so this is called attenuation. Okay, and what can we do? If I have a weak signal, I have to convert this into a strong signal. The process of converting this weak signal to strong signal is called as amplification, right? So this you have seen in, like, regular school assembly also, when principal sir is talking in a mic, his weak signal, his weak voice is being transmitted from mic to the speaker. So what's happened is it's amplification. You might have you might have used the amplifier also in your school, right? So it will take the weak signal coming out of our voice and it will convert into a large sound. So that is called as amplification. So the process of increasing the amplitude or the strength is called as amplification. Cool, right? You can see here the signal is increasing in strength or increasing in amplitude very drastically. So this is called amplification. Okay. Yeah. Cool then. So next, after amplification and attenuation, the next thing we are going to see is range. So what is a range? Range, for example, if your assembly is going on your school, and if there is somebody who is in the, like, very far away, okay, outside the school, can you hear that sound? No, we can't hear that sound, right? The voice will attenuate, will lose its strength as you travel farther and farther. So your voice is audible only for a definite range. So what is the range? So range is nothing but how long a signal can travel without reducing its signal. Okay, it's like the maximum distance, the largest distance possible from the source, from the person, and how far it can travel is called the range. Okay, so for example, you have a tower here, and this tower is transmitting the signal, and the signal can only travel up to this particular point. So that the distance between the source and the destination is called as range. The maximum distance is called the range of the signal. Okay. And the best example was me speaking. If I'm speaking in my home, a person who is 4 5 houses beyond me cannot hear my voice, because that's the range, right? It's out of the range. We while talking, we do say, right, your phone is out of range. I was out of range. So that means signal is not able to receive at that particular point. Okay. Yeah. Okay, so then there is repeater. So if I want the signal to travel a farther distance, what do I do? I use something called as repeaters. So what does this repeater do? For example, it's a very big company. Imagine it's Microsoft, okay, and they have a very big building. But the problem is they have only one Wi-Fi working. All the Wi-Fi are not working in those company, and there's only one Wi-Fi router there. So, but with just one Wi-Fi, can everybody in the tower get the signal? No, because the range is very weak. Only these many people can get the internet. But what we can do is we can install something called as repeaters. We can install something called as repeaters. So these repeaters will take the signal, it will amplify them, and they'll send them out again. Okay, I'll use one more repeater here. I'll use one more repeater here. They take the signal, they amplify, they send it. So by using repeaters, I can increase the range of the signals. I can increase the range of the signals, and they're really used everywhere. Okay, for example, see, in this kind of mountain terrain, we can't install the big towers. So we can install small repeaters, so they can send the signal. They'll catch the signal, they'll amplify, they'll send. This will again catch the signal, and it will resend it. So this is called repeater. Okay, cool, right? Am I clear, guys? And one small concept before I revise all of this together is uh, two kinds of signal. Okay, when I say strong signal or weak signal, what does it mean? Okay, so a strong signal is a signal which have lot of frequency. See, when this has lot of frequency, that means it has high energy, because we know that E is equal to h nu. If frequency is high, that means energy is high. Okay, so this signal has high energy because it has high frequency, therefore it has high energy. And if it has high energy, it can be transmitted to farther distance. It can be transmitted to farther distance. Okay, and now if you see the old signal, see, this has very less frequency, so this has very less energy. This has very less energy. So what happens? So this will have low frequency, therefore low energy, and therefore low range. Therefore low range. So energy is proportional to, you could directly say, the range. Okay, cool, right. So now I'll come back again to the block diagram and I'll explain it. Now I think you can understand better. Okay, so what I'm trying to do now is very simple. There is a person who is giving out the input. Okay, this input signal will be converted into electronic signal, because electronic signal is better to transmit from one point to another point by the help of a transducer. I use transducer and I convert my audio input signal to electronic signal, and they travel through my earphones to the laptop. Okay, so laptop is the processor here, and that laptop will process my signal, and it will transmit. Okay, it will transmit. What do you know what a transmitter is? It's a device which will send out the signal. Okay, my laptop can be a transmitter, and it will transmit my signal to a nearest tower, and the tower also acts as a transmitter. It is sending out signal everywhere in the form of electromagnetic wave, like a radio wave or a microwave. It sends out, and that radio wave is again caught by some tower near you, okay, which is a receiver, and that receives the signal and in the form of EM waves, and the receiver will provide your mobile again the same signal, okay, in the form of electromagnetic wave by that's called as receiver, right? And that mobile will convert that signal, electrical signal, into again an audio wave by something called as a transducer. Okay, so now which was electrical signal is clearly audible to you in the form of audio wave. Okay, so am I clear, guys? Is the block diagram clear here? Do you have any doubts? If you have any doubts, let me know. Okay, so let me know if you have any doubts with respect to the block diagram. If you have any doubt in any step, let me know. If everything is clear, click on yes. Okay, and the whole chapter is similar, guys. Like it's just like a telling story. So this happens, from this point to that happens. There was a king, and he goes to make a war, like same, like it's a story, right? The whole chapter is a story. It's a theoretical chapter, not much physics here. If I clear, click on yes. Okay, if you have doubt, you type the doubt, or you can click on no. YouTube, guys, am I clear? Okay, cool then. Okay, try to respond quick so that there is no need for me to ask you again and again. Okay. Okay. So by this, I can easily say that first part of the chapter is over. So I told you that I'll be dividing this into three parts, right? So first part was the basic components. So basic components we have understood. What's the signal? What's a transducer? What's a emitter? What's a repeater? We have understood, right? Now we'll try to understand how do we send a signal from tower to tower, right? How do we send signal from one point to other point? We'll try to understand. Okay. So let me write a diagram now. So there is one tower here, there is one tower very farther away. Okay, and there is one signal coming from my place to this tower, and this tower will transmit it, and this tower is receiving it. It is receiving it, and it will send it to you. So now I'm concerned in between what is happening in between these towers. Okay, and what I am going to include is sending a text message is different from sending a voice message, and it is different from sending a video message, right? And it is different from sending just a photograph, not video, it's a voice, right? And it is different from sending a JPEG format, right? JPG or an image. So these are different. So how do we send different information, and how can we differentiate all of this? We'll see that. And what are the ways we can transmit the signal from tower to tower? One is we can send directly. If the towers are very close, I can send them directly. If the towers are very far, I might have to use satellites. So we'll see this in the second part. Okay, so now let me tell you how do we differentiate text, voice, audio, and email, all of this. Okay, so we differentiate them by using something called as bandwidth, width of the band. Okay, so what is the band here? The frequency band. So frequency bandwidth. So what I'm trying to say here is, for SMS, I don't need that much amount of data, right? A very small amount of data is required. So a small wave, a small frequency wave, a low energy wave can take the SMS without any problem. But if I'm talking to you, I need some more strong waves with higher frequency, right? Higher frequency. I need some wave to send my voice. If I'm watching a video, then that means it requires much more higher energy waves for video, right? So we usually we're having different signals for different SMS, and what matters here is the bandwidth. Okay, so you can see here in the diagram, voice is having a different kind of signal than the text. So text, you can see it is very weak here. There are only some lines in between. But if you see voice is bit. If you see picture has much more density than the text SMS. And if you see voice is a more has again more density than these two. But if you see the video is very dense because it's carrying much more information, right? So these are different kinds of signal. Okay, in this diagram, what I'm trying to say is, okay, so you can see the different kinds of signal with the different kinds of energy. Okay, later on, what do I particularly mean by bandwidth? Okay, to send a SMS message, I can use low frequency bandwidth. To send a video message, I need high frequency bandwidth. So let me show a diagram here, which will make you clear. So, for example, imagine ship. There's a ship, and the ship is trying to communicate to a person who is near the ground. So he just says that I'm all right, everything is fine. He doesn't use much information to there is not much information to send from the ship to there, right? So what we use is we use very low frequency. We use very low frequency signals, and signals from 3 kilohertz to 30 kilohertz are called as very low frequency VLF. LF is lower frequency, MF is more frequency, HF is high frequency, VHF is very ultra high frequency, UHF is the VHF is very high frequency, UHF is ultra high frequency, SHF is super ultra frequency, and what is it? I can't see it, which is EHF, extremely high frequency, extremely high frequency, and a frequency which is from 3 kilohertz to 30 kilohertz is called as very low frequency. A frequency from 30 kilohertz to 300 kilohertz is called as low frequency. A frequency which is from 300 megahertz to 30 megahertz to 300 megahertz is called as very high frequency VHF. Cool, right? So this is called the bandwidth. From this width to this frequency is called the bandwidth. So if I ask you what is the bandwidth of VHF, you say that uh, 30 to 300 megahertz is called the frequency of ultra high frequency. It's a bandwidth. Okay, and these are all called a band. So this is the band of very ultra high frequency, and this is the band of low frequency. Okay, and as the signal is very strong, for example, if you are using 4G or if you're using TV, you need ultra high frequency. If you're using an FM radio, you need very ultra high frequency. And if you are having much more information to travel, like very huge amount of data, and if you want satellite is super ultra frequency or extremely ultra frequency, extremely ultra frequencies. Okay, cool, great. And so as I move on here to the next concept, the low frequency operates from 30 kilohertz to 300 kilohertz. So 300 kilohertz is called the highest frequency, 30 kilohertz is called the lowest frequency, and the difference between these two is called the bandwidth. Difference between these two is called the bandwidth. So now if I ask you, what is the bandwidth of ultra high frequency? What is the bandwidth of ultra high frequency? You check. So you go to ultra high frequency, you see it is 3 gigahertz. Like it is 3 gigahertz. And what is the lowest frequency of ultra high frequency? 300 megahertz or zero point 0.3 gigahertz. So what is the bandwidth? The bandwidth is 2.7 gigahertz. So 2.7 gigahertz is the bandwidth of ultra high frequency. Okay. Or if I ask you what is the bandwidth of very ultra high frequency, you divide, you subtract 300 from 30, you get 270 megahertz. So 270 megahertz is the frequency of, the bandwidth of very high frequency VHF signals. So am I clear with bandwidth, guys? So bandwidth is the operating region of that particular signal. Okay, and every different frequency can carry different kind of information. As you can see here in a previous diagram here, for video I need high frequency. For text I can use low frequency. So which is better for video here? Ultra high frequency is better for video. And what is the bandwidth of that? 3 gigahertz to 300 megahertz. Okay, and when you talk about radio, the radio will be like 98.6 big FM, 93.5 red FM, right? So they're nothing but megahertz. 98.6 is a megahertz, and 93.5 is also the megahertz. So see, you can see the FM radio works in a very ultra high frequency, and it lies between 30 megahertz to 300 megahertz. So somewhere here near the 100 megahertz region, we do use operation for FM radio. Cool, right? So am I clear, guys? So am I clear what bandwidth is? Okay, click on yes or no if I'm clear with the bandwidth. And YouTube guys, you can comment me in the chat box like, sir, okay, clear. Can you explain once again? Okay. Yeah. Zoom guys, am I clear? Click on yes if I'm clear. Okay, good then. Okay, yeah, better. So yeah, so now we know how to differentiate audio and video, how to differentiate audio signal to video signal. We're clear with that. And let me come back to how do we send a signal. We know that from one antenna, from transmitter antenna to receiver antenna, the waves are traveling in the form of electromagnetic radiation, mostly in the form of radio or in the form of microwaves, right? And what are the different kinds of transportation? Like we have roadways, airwaves, and the railways, right? Similarly, what are the different kinds of transportation we have from one antenna to other antenna, and how many different waves I can send? Okay, so there are basically three different kinds here. One is called the ground wave, then other is called the sky wave, then other is called the space wave. Okay, so ground wave can carry signal of very low frequency, like 2 hertz. Okay, 2 to 3 hertz. The ground wave can carry very low signal, and a sky wave can travel take 3 hertz to 30 hertz. Okay, sorry, 2 megahertz. From 3 megahertz to 30 megahertz, it can carry signal from 3 megahertz to 30 megahertz. If you want to use something more than 30 megahertz, what you have to do is you have to use space waves. Okay, for different strength of signal, use different kind of transportation. If you want to travel very slowly, you use roadways. If you want to travel very fast, use airways, right? Similarly, if you have a weak signal, use ground wave. If you have a medium signal, use sky waves. If you have a strong signal, use space waves. And how do they travel? We'll see step by step. Okay, so in ground waves, it's very simple. Okay, from a person from point A to point B, there are two towers, and these two towers are very close to each other. They're not farther away. They're very close to each other in a few distance of kilometer range. Okay, they're very close, and since they're very close, they can send a signal from one place to other place directly, from one place to other place directly. And these kinds of waves are called as ground waves. Okay, so what if somebody asks you what is ground wave? They're very weak signal which carry very low energy waves to a nearby points. Okay, very simple. And let me come back to some statistics of this ground wave. Okay, for example, imagine I'm sending a radio wave, okay, which has 100-meter wavelength. The wavelength of this radio wave is 100 meter. So what should be the height of the tower? So few engineers did experiment on this, and they told that if the height of the tower is 1/4 of the wavelength, if height of the tower is 1/4 of the wavelength, only then the transmission is very good. If you have very less height of tower, for example, if 100 meter is a wavelength of the signal, at least the tower should be 25 meter long. If you use lower length towers, then the signal will not be transmitted very clearly. There will be a weak transmission of signal. So this is what engineers found out. Okay, so they told that at least the height of the tower should be 1/4 of the lambda. Okay, so this question can be asked directly in JEE. So if the ground has some wavelength, what should be the minimum height of the tower? They can ask you directly. So if you divide by 4, you'll get the answer. Okay, so these are very simple kind of question which can appear in JEE. So pay attention. Okay. So engineers told that at least 1/4 of the wavelength should be the height of the tower. Okay, and the problem here is, of course, yeah. So they'll have large distances, large physical size, because if you want to travel signal from one point to one point, then the problem will be they'll be having very large signal, right? I mean, a large signal will have a very high tower. So that's a very big problem to us. Okay, so ground waves are not used in very long communication, and there's one more reason. The reason is, since they're traveling very close to the ground might absorb some of the radiation, and as it travels from one point to other point, it get attenuated. It becomes weaker. As it's going from one point to other point, it becomes weaker and weaker. It's called attenuation, as I already told you. So it becomes weaker and weaker since it is very close to the ground. So we don't prefer ground wave because the height is not manageable, not constructible, and it gets weaker and weaker because due to the absorption of the ground. Since they're very close to the ground, since they're called ground waves, they get absorbed and they can't travel very farther distances. Okay, so then people came with an alternative called sky waves. And what do the sky waves do? Okay, very simple. Okay, so what happens is you have a tower somewhere near the earth. Okay, and this tower will send out radio waves. Okay, radio waves or microwaves, radio or microwaves to the earth atmosphere. And we know that earth atmosphere has stratosphere, troposphere, right? Troposphere, we have troposphere, then we have stratosphere, then we have mesosphere, then we have exosphere. And in exosphere there's something called as ionosphere also, right? So we have different kind of earth atmosphere, different layers of earth atmosphere. And what happens is, we don't send a signal to tower directly now. We are sending the signal to a particular region of earth atmosphere. The signal keeps on traveling. It will enter stratosphere, it will enter troposphere, it will enter mesosphere. And when it reaches to ionosphere, ionosphere has a very special property, and it will reflect some amount of radiation back to the ground. Okay, it usually transmits, if the signal is of strength from 30 to 300 from 3 to 30 megahertz, it will reflect all such waves. Okay, whenever there is a wave which is of frequency 3 to 30 megahertz, the ionosphere has the ability to reflect all the waves. So what I do, when the rays are getting reflected, I'll keep one more tower here. Okay, I'll keep one more tower here, and it will receive all the signal. Right, very simple. Okay, very cool, right? So this is called skywave because the waves are traveling in the sky, right? They're not traveling near the ground. Since they're traveling near the sky, it's called as sky waves, and they reflect only a particular region of bandwidth, particular region of frequencies. Okay, for example, if there are less than 3 megahertz, what will happen? They might not reach the ionosphere. Okay, they might get weaker, and it's not very good to transmit weak signals. So what happens if I use more than 30 plus 30? What will happen? So if I use more than 30 megahertz, the ionosphere might not reflect it. They just go back. Okay, they just go into space like that only. Okay, without any change, they just refract and go. If you remember initially, I told you that waves, electromagnetic radiation undergoes reflection. They also undergoes refraction, right? So what's happening here? The ionosphere is reflecting the radio waves. Okay, and if it has more strength, more than 30 megahertz, the waves might go out of the earth atmosphere by getting refracted. But okay, nothing much will happen. They just get refracted and they'll move. Okay, so always remember, skywave are the wave which are getting reflected by ionosphere. The best range is 30 to 300 megahertz. Okay, so this is an average value. If you want more specific detail, I'll give you a formula. So the maximum frequency that which ionosphere can reflect is 9 times root of ion density. Okay, what is ionosphere? Ionosphere is made up of ions of different gas molecules. Okay, and if I take how many ions are there in a particular volume, that is called as ion density. Ne is called as ion density, and usually the maximum frequency this ionosphere can reflect is 9 into root of electron density or ion density. Okay, so this also might be asked in JEE. So again, this is one second formula which is important. Okay, so they might ask you, if the electron density or the ion density of ionosphere is um, 36 into 10 raised to 12, do you think it can what is the maximum frequency we can send? They might ask you. So let me frame that question and ask you here. So the ion density of ionosphere is 36 into 10 raised to 12. Okay, so what is the maximum frequency that ionosphere can reflect? Ionosphere can reflect. What is the maximum frequency? They might ask you. Then you write it as 9 into root of ion density. So 9 as it is. What is ion density? Ion density is 36 into 10 raised to minus 10 raised to plus 12. So 9 as it is, 36 is 6, and 10 raised to 12 root is 10 raised to 6. So you get 54 into 10 raised to 6 hertz or 54 megahertz. So ionosphere, which is having this much amount of density, can reflect up to a frequency of 54 megahertz. If it is more than 54 megahertz, it will not reflect, rather than it penetrates the ionosphere and it goes into space. Okay, and why is this? Because ionosphere is not uniform. Ionosphere is, sometimes it has high density, sometimes it has low density. So the density keeps on varying. So if this is ionosphere in between, so the density of ionosphere differs from point to point. Okay, and students, when I was in NITK, right? So I had went to this IIT Bombay, and those students in IIT Bombay were making a satellite called Pratham. Okay, and the Pratham was the first Indian student satellite, first student satellite of India, made by Aerospace Department of IIT Bombay. So there, those students, okay, so we were there working on the satellite for some days, and there, I mean, like for a few days, okay, and there was a ground workshop on building the ground station. to receive the signal from the satellite. We were there. And what was the satellite? The major objective of the satellite was to map the ionosphere. So it will map the ionosphere, how dense the ionosphere is from point to point, and it will measure accurately so that the signal which we get is more accurate. For example, I'll give you an example. Okay, take for example GPS. So you are opening Google Maps, and you are sitting somewhere in your home, but the map is showing that you are here. There is some error in the map, right? That is because of this ionosphere. Somewhere it is dense, somewhere it is not so dense. So signal will be disturbed. Distortion hoga signal ka. So what we do is we usually find out how much is the density here. We'll check for every particular region and we'll correct the factors. Okay, some signal is strong, some signal is weak here. So we'll find out a factor using mathematical analysis, and this satellite will map this ionosphere, and using mathematical analysis we can then predict the error, and then we can correct and we can predict the motion of this map to a very great accuracy. Okay, so yeah, see, that is why it's important. Like physics is important, right? Other without physics, we don't have a GPS, or we have a very wrong GPS. You are in some place and it's showing you that you're in some other place. Then that's a big mistake, right? Yeah. So, yeah, and in 2017, ISRO launched the satellite. It did some work. It's performed its work, and it is not working now. I mean, like the average plan was of 2 months. 2 months. It did work for 2 months. We collected. I mean, IIT Bombay students collected a huge amount of data, and they're looking forward to launch some other satellite, I hope. Okay. And the third kind of wave is called a space wave. Okay. So what if I have a very strong signal? Okay. For example, what if I have uh, a signal to transmit? So then I use something called as space waves. Okay. Or also called as line of sight communication. Line of sight communication. Okay. So how does it work? So this is basically, again, it is transmitted from one antenna to another antenna. Okay, it can be transmitted directly from one antenna to other antenna, or if you don't have this antenna, you can use a satellite. Okay, you can take a satellite here. This strong signal will penetrate the ionosphere, will go to the satellite, and this satellite will again capture the signal and it will send it to this tower. Okay, so it can happen in this particular way also. So see, the object here is this satellite can or should be able to see both the towers. So that is what it's called as line of sight. One tower should be visible to the other tower, or the satellite here should be able to see both the towers. Okay, so that is what it's called as line of sight communication, and it's called space wave because it can exit the Earth atmosphere. It can goes to like the outmost layer, the space. Okay, that's what it's called as line of sight communication. And if you notice, it's traveling everywhere in a straight line, right? It's not getting radiated out, but it's trying to travel in a straight line. Okay, and frequency about 30 or 40 megahertz are better for this kind of wave transmission. Okay, because they are very strong waves. Here, if I use sky waves, they will be not reflected back by ionosphere. They go away. So we are using a different kind of communication called space wave. Okay, and let me tell you how does it work. Okay, so what happens is, imagine I have a transmitter antenna. I have a transmitter here, so this will send a signal out, and the height of this tower is HT. Okay, and I don't have a satellite. I'm living very old. I'm living in 19th century, imagine, and I don't have uh, a satellite. So how does this signal transmit? So the signal is transmitted, and it is traveling along this line, and it will reach this maximum point. Okay, imagine if I'm sitting here. If I'm sitting here, I can't receive the signal because the signal will travel in a straight line, and it will miss me. Okay, so the maximum distance is I can catch the signal if I'm here, right? So this is called the distance of transmitted signal. Okay, or also called the range of the transmitted signal. Am I clear? So let me tell you once again. So there is a tower of height HT, and its effective distance to transmit is called DT. Okay, and this is a point of effective distance it can transmit. I can use Pythagoras theorem and I can determine DT without any problem. Okay, so imagine what I do is now I have a transmitter signal here. Okay, I have a transmitter antenna, and the maximum distance I can get the signal is DQ, I mean point Q, and that distance is called as DT. So this is the range of the signal which can travel. Okay, so now I'm going to construct a right angle triangle. Okay, from the top of the tower to this point on the horizon and to the center of the earth. Okay, so now I consider a right angle triangle. Let me write the Pythagoras equation. So PQ, what is PQ? PQ is the distance or the range. Okay, and what is QO? QO is the radius of the Earth. And what is PQ? PQ is height of the tower plus radius of the Earth. So if I apply the Pythagoras theorem, I can easily say that P square, PQ square plus QO square or OQ square is equal to OP square, hypotenuse square. Right? Simple. And I can now write PQ. What is PQ? PQ is height of the tower plus radius of the earth. This distance here is radius plus height of the tower, right? So let me put that here and I'll expand it. Height of the tower plus radius squared. Use the regular formula. Okay, the second power formula, expand it, r square 2h rt and ht square. So what happens here is r square and r square cancel out because there is r square on both the sides. Write down the remaining expression. Okay, and if you compare height of the tower to radius of Earth is 6,400 kilometers, very huge, but height of the tower is only a few meters. So the ht square will become some much more smaller. So I can neglect this since it is very small compared to radius of Earth. I can neglect it, and I can directly write that dt square is equal to 2rht. Okay, or the maximum range of the signal is equal to root of 2 times radius of Earth into height of the tower, radius of Earth into height of the tower. Okay, and again, people might ask you question on this in the regarding what is the maximum range of a space wave. Okay, so they can do this. Okay, so let me do it very quickly again. So very simple, nothing much here. Okay, so I had a height of a tower ht, and it is transmitting a signal to a particular point. Okay, and this is the maximum range. Okay, if I'm sitting here, I can't receive the signal, nah, because the signal will travel, space wave travels only in straight line, so I can't receive it. Okay, so what happens is, let me draw a Pythagoras theorem. So what happens is very simple. PQ square plus OQ square becomes PO square. Expand it very slowly, very clearly, you get this formula. Okay, and subsequent solving and taking height of the tower is very small and height square is very small and close to zero. Okay, oh, not this, close to zero. You can neglect them and you get this very simple formula where maximum range is equal to root of 2 times radius into height of the tower. Okay, so this is done only by the receiver tower. What if I keep one more tower here? What if I keep one more tower to receive the signal? Okay, we'll see that also. And there is one more parameter called surface area of the signal. See, this signal can be sent here, this signal can be sent here, this signal can be sent here, this signal can be sent all over this particular area, right? So this area will be equal to pi r square. That's all. And what is the radius? Radius is equal to this particular value here. Okay, root of 2rht. So therefore, pi r square is the area of the space wave, and pi times square of dt is 2hrt. So this is the effective area in which the signal can travel from one point to other point. Cool, right? And similarly, if I have two antenna, one antenna has a transmitter antenna and one antenna has a receiver antenna, if I have both of them, okay, so the transmitter antenna can transmit the signal up to uh, root of 2 times radius of Earth into height of the tower t. Okay, so up to this distance it can transmit. Okay, cool. And if I have a receiver antenna of distance hr, height of the receiver is hr, then it can pick up the signal by for a distance of 2 times root of height of the tower, receiver height of the receiver tower. Okay, so therefore the maximum distance which is space wave can travel is root of 2rht plus root of 2rhr. Okay, so that's the maximum distance or the maximum range of line of sight. Cool. So one tower, the transmitter tower can transmit signal up to root of 2rht. The receiver signal can receive signal up to a distance of 2rhr under root. So the total distance will be sum of these two. So this is the maximum line of sight distance or maximum range of the signals what we get. Okay. Am I cool, guys? Are we clear here? So let me wind up here by combining all three waves. Okay. So I have my globe here. I have height of the transmitter tower and I have height of the receiver tower. Okay. So if I use ground waves, what will happen if I use ground waves? So ground waves can't travel farther distance because they are of weak signal. So ground wave are only up to magnitude of 2 to 3 megahertz, 2 to 3 megahertz. So they are very weak, so they can't travel very farther. That's a drawback with them. And when they always travel very close to the ground, so when they're traveling close to the ground, they become weaker and weaker as they go towards, they get attenuated. Okay, and we know that engineers told that height of the tower should be approximately equal to 1 by 4 of the wavelength it is sending. Okay, so this is the first formula of this chapter. The height of the transmitted tower for ground waves should be approximately equal to 1 by 4th of the wavelength which is traveling. For example, if I am sending a wavelength of 100 meter, the height of the tower should be 250 meter, 1 by 4th of the wavelength. Okay, 250-meter tower is very, very huge, very, very large. So ground waves are not very good to communicate for longer distances. Okay, then comes sky waves. So what does skywaves do? So skywaves basically sends the signal to outside the Earth atmosphere, and those signals are reflected back by the ionosphere. Ionosphere reflects back all the signal, and it will send you to one more tower. Okay, and it is very good to send signal which is of 3 megahertz to 30 megahertz. Okay, these kind of signal will travel very easily, very quickly without any problem. Okay, if I send higher frequency, what happens is they penetrate the exosphere and they go back. Okay, so I can't use a very high strong waves because they can penetrate the ionosphere and they go back, and I can never receive them again. So I'll use only certain range, and we have one more formula here. So the maximum frequency that a wave can be reflected back is 9 times root of Ne, where Ne is the ion density of ionosphere. Okay, cool, right? Yeah. So this is about sky waves. But again, sky waves, if I have very strong waves, I can't transmit them. So I use something called space waves. So space waves are very strong waves which can transmit more than 30 megahertz. They can transmit signal which are more than 30 megahertz. Okay, so what they do is they can send signal in a straight line, and they travel in a straight line from point to point. And so they're called as line of sight communication. Line of sight communication. And the maximum height, sorry, the maximum distance that a transmitter can travel is distance of 2 times root of 2 times radius into height of the tower, and maximum distance a receiver can receive a signal is 2 times radius of into height of the receiver. Okay, and therefore the total maximum distance a signal can travel in space waves is 2 times h of t into radius plus 2 times h of r into radius of earth. So this is the maximum distance or maximum range of line of sight. Okay, so remember these three formulas. Okay, so there are only 4 formulas in this chapter, and out of which one question is very mandatory. Okay, very high probability we have. So one is this one. Okay, other is this one here, and other is this one here. Okay, cool, right? Okay, and later on, when satellites were invented, so again we use space waves because space waves they're very strong. They penetrate the ionosphere. See, they penetrate the ionosphere. They come back to the receiver antenna. But again here, these satellites should have line of sight communication. That means both the towers should be visible to the satellite. Okay, and by this we now have bit more extra range. Okay, cool. Okay, so am I clear, guys? Am I clear with ground waves, sky waves, space waves? There are 3 respective formulas for this, and the basics of communication. So what's the transducer, transmitter, signal, all of this. Am I clear? So click on yes if I'm clear. YouTube guys, am I clear? Respond in the chat box. Okay. YouTube guys, Zoom guys, am I clear? Click on yes if I'm clear. Okay. If you have any doubts, click on no. If you have any doubts, click on no. Sir, I have some doubt. I have not understood. Click on no. Space wave, 1 second. Okay. So what happens to space waves? Space waves are very strong waves which can penetrate the ionosphere. They can penetrate the ionosphere, and it's called line of sight communication because this tower here should be visible to tower here. Okay. So there are 2 ways. One way is you send one tower to one tower directly. Okay, that's also called line of sight communication. Or if you use a satellite, then again this satellite should be visible to both the towers. Okay, so that you can take the signal from one tower and send it to other tower. So this is called space wave communication. Okay, if I'm using very strong waves, the maximum distance the waves can travel is root of 2r height of the tower. Okay, and the maximum distance a signal can be received is 2 times root of radius of Earth into HR, height of the receiver tower. Okay, so this is the maximum distance which is possible to transmit, and this is the maximum distance which is possible to receive. Therefore, total distance, maximum distance of the range of this kind of communication will become 2RHT plus 2RHR. Okay, cool, right? Yeah, so this is of space waves. Okay, yeah. So my one doubt here, I have a doubt here. Okay, so since the towers are common to all the people, there are millions of people living in a city, right? So what I'm talking in a phone, and similarly my brother is talking to a phone. Don't you think? Okay, my signal and my brother's signal. Okay, don't you think they interfere and they mix it up? They mix up, and it's very tough for the signal to understand whose signal is it. Okay, so then how do you think we can separate the signals? Any idea, guys? Do you have any knowledge about this? Have you thought about this anytime? Right? Because see, there'll be thousands of people in small village, and they'll be talking in the phone. If there are many people talking at the same time, don't their signal get mixed up? They don't get mixed up, right? So to avoid this kind of mixed up, we use something called as frequency modulation. Similarly, there are lots of radio stations, but whenever you switch on to a particular radio station, you get particular information. You won't get a mixed up information, right? So again, that is due to modulation. Okay, we'll see what modulation is, and this is the last part of this chapter. So there are mixing up of signal always at the transmitters. For example, imagine there are three different people at three different radio stations that speaking continuously. So their signal can mix up, and it can create noise and interference, and it becomes very chaotic. Okay, so what we have a solution, and what we do to solve this is something called as modulation. Okay, so see, his wave is converted into different form, his wave is converted into different form, and the third person wave is looking in a different form. So we have changed the frequencies, and changing the frequencies or changing their amplitude or changing the properties of wave is called modulation. Modulating, you're making certain changes, and these are called modulation. Cool, right? And there are three kinds of modulation: amplitude modulation, frequency modulation, and phase modulation. Okay, so we'll see what they are. And before that, let me tell you something much more about modulation. So how does modulation work? For example, and we can use modulation uh, also to make the signals travel farther distance. If there's a wave signal, it can't travel farther distance. But if I modulate a wave, I can make sure that the wave can travel farther distance now. Okay, so there are two uses of modulation. One is to avoid mixing, and second is to make sure it can travel for a farther distance. So how it happens? So students, very simple example. Imagine you have paper with you, on a regular paper. If you want to throw this paper to a farther distance, no, they won't travel. So this is a weak signal. Imagine paper as a weak signal. If you travel this paper to a farther distance, no, they won't travel. They fall very closely to you, so they can't travel, right? But what you do now is you take a stone, okay, and wrap this paper around the stone, and now you throw. So this stone can travel very farther distance, and paper also is traveling along with the stone, right? And now this can travel very farther distances. And this process called as modulation. The combination of signal to some other thing is called modulation. Okay. So here paper was my signal, stone was my carrier. It was carrying my signal. When I combine both of them, it becomes modulation, right? Paper plus stone is called as modulation. Similarly, weak signal plus strong signal is called as modulation. Now, when weak signal is placed with the strong signal, it can travel very farther distance again. Okay, it can travel farther distance. But you don't want the stone. Stone is extra helping here, but you only want the paper. So what you do, you separate the stone and you separate the paper. The process of separating the paper and the stone is called as demodulation. Demodulation. Okay. So stone is a carrier thing. You don't want it. You throw it away. You'll read what's the information in the paper. Okay. Very simple. So this is called modulation, demodulation. Or one more better example is, okay. So for example, imagine there's a king here in one kingdom and there is a queen in other kingdom. Okay, and they're living very in a very old time, so they don't have phone to talk to each other. So what they do, so he takes uh, paper, he writes information to her, and he takes a pigeon and take it to the neck of a pigeon, I mean the feet of a pigeon or neck of a pigeon. So pigeon here is a carrier. Okay, and this is the signal, and this process called as modulation. So the king has modulated the information now. So what happens? This modulated signal will travel very farther distance, and she now can take the paper out, and she don't want a pigeon anyway, right? Who the hell wants a pigeon? So they take the pigeon out and they send it back. She'll take the paper and read the message. So this is called demodulation. This is called demodulation of signals. Okay, bas, ho gaya. And so remember two terms here, carrier and signal. Carrier and signal are two very important things here. Okay, so same thing happens in signals also. So what is modulation? So there's a weak signal which you want to transmit, but it can't be transmitted because it is weak. So you combine them. Okay, you combine them using very strong frequency, very high energy frequency. Both of them gets added algebraically. Sorry, both of them gets added vectorially, like in 11th wave optics or in wave chapter. You do write y is equal to y1 plus y2 for constructive interference and for destructive interference. So this becomes a1 sine omega t plus b cos omega t. So this is how you combine waves, right? Exactly in the same way they combine, and finally you get with a modulated wave. You get a modulated wave. Okay, and this is called as modulation. So this was a weak signal. You combine weak signal with a strong carrier wave like a pigeon or the stone. When them both mix together, you get a modulated wave. So this is called a modulated wave, and the process called as modulation. Okay, yeah. And so remember, the amplitude of a weak wave is called as AS, amplitude of signal. The amplitude of carrier wave is called as AC, and the highest amplitude of modulated wave is called as AM. Okay, amplitude of modulated wave. And there is a mathematical term to tell which is better wave of modulated. So there is something called as modulation index mu, which is amplitude of modulated wave by amplitude of carrier wave. So if there is good modulation index, that means the modulation is very good. Okay. Acha, go slower. Okay, okay, cool. So yeah, cool, right? So I'll repeat it again. So there are three parts here. So a very weak signal, which is amplitude AS, is being combined with a very strong signal, which is called a carrier wave. And when both of these two gets combined, we have modulated wave. And this modulated wave, it has different amplitude. I'll consider the most highest amplitude AM, and we define a modulation index mu as AM by AC, amplitude of modulated wave by amplitude of carrier wave. So how did I get this formula? I can derive this formula without any problem, but the issue is derivation is not much important. Okay, so let me tell you how to derive it. Okay, for example, this wave equation is given by amplitude of signal wave sine of omega t minus kx. Okay, and sim omega 1, I'll write as omega 1, and I'll write this wave equation as this is y1, this is y2. Y2 is equal to amplitude of carrier wave sine omega 2 t minus kx. So these are two different wave equations. If I add both of them, I get carrier modulated wave. So y is equal to y1 plus y2, which is as sine omega 1 t minus kx uh, plus a carrier, and same that equation. If you add both of them algebraically, sine a plus sine b, use the formula. If you solve this complete step complete process step by step, you'll get a constant called this value. It is called the modulation index AM by AC. It's a constant value. Okay, so derivation is not that important. If you know this for JE, it's more than sufficient. If you want the derivation, you can refer NCERT book. Okay, they're given the derivation. Okay, but I'll skip the derivation because it's not that important. Okay, and this is called as modulation. And but here in this modulation wave, there is carrier wave, there is signal also. I want to separate them, right? And the process of separating them is called as demodulation. So what you do, you take the demodulated wave, you remove that carrier wave, that high frequency, high energy carrier wave, you remove the pigeon or you remove the stone. What you're left with is the information. What you're left with is the signal. And this process called as demodulation. This process called as demodulation. Am I clear, guys? So am I clear, guys? If I'm clear, come on, respond with yes or no. Okay, two things. What is modulation and what is demodulation? Did you understand the process? And can you remember the modulation constant, the modulation index? Zoom guys, respond with yes or no. YouTube guys, you can respond with in the chat box. Okay. Okay. Cool. Waiting for you guys. Respond quickly so that I can continue to next the last concept. Okay. So this will be over in 10 minutes, 5-10 minutes. So no worries. Okay. Yeah. If you don't understand, also you're free to say you're free to tell, sir, I don't understand. Repeat again. So you're free to tell that also. Okay. Come on, it's a free country, bro. Okay. So the last concept is types of modulation. So this modulation I told you, right? So there are three ways of modulation. Acha. Okay, Nikita. So I mean, this is the last concept. Okay. So we'll wind it up here. Not a problem. Okay. So let me end the chapter here very quickly. Then I can revise you if you want me to again. You can go through a very brief of all the things we are taught. So we have learned a lot today, right? Yeah. So let me stop with here the types of modulation. So there, when you have wave, okay. So what do you have? There is a particular amplitude for the wave. There is particular wavelength frequency, right? So if a wave is traveling very fast, that means it has a lot of frequency, and it also has something called as phase angle, the initial original angle or called phase. So there are three important parameters for any wave. One is called the amplitude, the other is called the frequency, other is called the initial phase. Okay, so for example, if I write y is equal to a sine omega t minus kx, so you can see all the three parameters here. Okay, so this a is called the amplitude, this omega is called the frequency, this whole term is called the phase phi. Okay, so whenever I modulate, either amplitude changes or frequency changes or phi changes whenever I combine two waves. Okay, therefore I have three kinds of modulation. So one is the amplitude modulation when amplitude changes, right? Other is called the angular frequency modulation or frequency modulation, and the third is the phase modulation. So I have three kinds of modulation: amplitude modulation, frequency modulation, and phase modulation. And in radios we see FM radio, right? There they operate under frequency modulation. So they operate under frequency modulation, so they are called as FM radio. Okay, so I'll show you how do they look in simple diagrams. Okay, so this is how amplitude modulation looks like. So there's a weak signal, okay, and there's a carrier signal. Okay, when I combine both of them, see here, everywhere the amplitude is different. If I take this circle, you notice at every point, if I make a drawing here, initially the amplitude was less, it goes on increasing, the amplitude decreases, increasing amplitude, maximum, now decreasing amplitude. So amplitude is varying here. Okay, so that is why we call it as amplitude modulation or AM. If the final modulated wave has different amplitude, it is called amplitude modulation. Okay, if you check the frequency, see, for every particular second, one wave pulse is moving. After 1 second, this wave pulse moves. That's it. After 1 second, this wave pulse moves. So frequency is constant. And angle is also seen for all the particular waves. The phase is also constant. Only amplitude is varying, so it is called as amplitude modulation. Am I clear, guys? So let me repeat again. If the final wave has different amplitude, if I make a box here, if I check here, see, initially there was less amplitude, now the higher amplitude, less amplitude, higher amplitude. So different amplitude wave is moving here. So this is called as amplitude modulation. Okay. And later on, if I take a wave, a signal wave, and combine with a carrier wave, and if I get this kind of wave, see now the amplitude is same. All of them have the same height, same amplitude. So amplitude is constant, completely fine. Phase is also constant. But if you check, if I make a box here, you notice sometimes many number of waves are passing, sometimes only few numbers of wave are passing. So frequency is different. Frequency is different. So this is called as frequency modulation. This is called as frequency modulation. Okay, very simple. Am I clear here? Okay. And lastly, we have phase modulation. So I take a signal wave, I combine with the carrier wave. If the resultant looks like this, see, it doesn't have a constant amplitude, it doesn't have a constant frequency, and therefore it doesn't have a constant phase. All three are varying here, and this is called as phase modulation. This is called as phase modulation. Very simple. So let me come back to all these three again. So first one is when I combine, when I have a wave, there are three aspects for a wave: amplitude, frequency, and phase. When amplitude is different in the final situation, we call it as amplitude modulation. For example, here I had a signal wave. Okay, this was my signal, and I had a carrier wave. When I combine both of them, when I modulate both of them, notice here amplitude is different at every point. So this is called amplitude modulation. Okay, and in third case, if I take a carrier wave and a signal wave, I see the amplitude is same. All the height of the wave are same, so amplitude is constant. But if I check how many waves are passing at a given time, sometimes see now only few waves are passing. Now high number of waves are passing, so frequency is different. So they're called as frequency modulation. Okay, and lastly we have phase modulation. If both amplitude is varying, if both frequency is varying, and if both of them varies, usually phase also changes, and this is called as phase modulation or PM. Okay. Yep. So by this, I can say that the chapter is over. Okay. So let me have a very quick revision, 5 minutes, so that you remember everything. I mean, really, right? You guys are amazing because I taught huge amount of data today, but you sat patiently and you heard my class. Thank you. Okay, I'm happy for all of you stay till the end. That's good. Okay, and good evening, Vishalis from YouTube. Okay, yeah. Okay, so what's happening here is so I'll divide. Okay, so let me do the revision so that you remember very clearly. So I divided this chapter into three parts. The first was the basic component of communication system. Next part was the ways of communication, the ways of communication, and the third part was modulation. Modulation. Okay. So what was basic? What was the basic concept, guys? The basic concept, what I thought it was the basic terminology. So, for example, like what is a signal? So we learned what a signal is. Signal is useful information, and we learned what is a transmitter, which sends out the information, and we learned what's the receiver, which receives the information, right? So these are the two simple things which we learned, and we also learned what is a repeater, right? What is a transmitter, receiver, repeater? What is attenuation? Attenuation is the weakening of signal. As it goes further and further, the signal becomes weaker. That is called attenuation, and increasing the strength of this signal is called as amplification. Amplifier. We use amplifier, and that is amplification. And we learned about something called as transducer. So transducer is it's like my microphone. It converts my audio waves into electrical signal, convert one form of energy to other form of energy. It is called as transducer, right? So we saw some basic concepts of communication system, and also we saw the block diagram, right? How does the waves travel from one point to other point by using a block diagram? We learned that, right? And later on, we came back to the ways of communication. So there are particularly three waves of communication. One is by ground waves, which can carry very weak signals for only short distances. Okay, and for this criteria, his height of the tower should be equal to 1 by fourth of the wavelength of the signal it's traveling. For example, if the wavelength that the tower is transmitting is 1000 meter, the height of the tower should be 1000 by 4 to 50 meter. Okay, like that. And this was the first way. And second kind of communication from tower to tower. So one tower to one tower, ground we can send by ground wave, or from one tower to other tower we can send by sky waves. So what are sky waves? So sky waves are the waves which are reflected back by ionosphere. Reflected by ionosphere. Okay, and for example, 3 megahertz signals to 30 megahertz signals are reflected back by ionosphere. So I send some signal of this strength, which is very much greater than this ground wave. They go to the ionosphere, they get reflected back, they come back and reach the other tower. Okay, and the criteria here is the maximum frequency of a sky wave can be equal to 9 times root of NE, where N is the ionization density, ion density of the sky wave. Oh, sorry, of the ionosphere. Okay, and lastly, we saw space wave. What is space wave? Space wave or line of sight communication can happen from tower to tower in a straight line, or from tower to satellite. From tower to satellite. Okay, then from satellite to tower, but always remember they're always traveling in a straight line. And the maximum distance they can travel is 2 times radius of Earth into height of tower plus 2 times radius of Earth into height of receiver. So this is the maximum range of the space wave. We already derived the formula also, right? So pay attention to that. Okay. Yeah. So later on, lastly, we saw modulation. So why do we use modulation? For two purposes. One purpose is to make sure that they travel farther distances, and next was to make sure they don't mix up, to avoid mixing up. Okay, so we use modulation. So modulation is combining weak signal with a strong signal, with a strong signal. So signal has a carrier with it, like a stone or a pigeon, the pigeon example, right? Or the sign. So remember those two, use both of them. And when you add both of them, you get a final wave called modulated wave. Okay, if modulated wave looks like this, if it is changing in amplitude, then it's called as amplitude modulation. If modulation wave looks like this, okay, amplitude is same, but frequency is different, then it's called as frequency modulation. If amplitude waves looks abrupt, like like this, then it's called as phase modulation. Here phase is changing, amplitude is changing, and height is also changing at every point. Cool, right? Yeah. So this is the whole chapter of communication system just in one slide. So if you want, you can take a screenshot, or yeah, you can go through the notes which I am going to upload without any problem. Okay. And lastly, let me write the formula for, I'm going to erase all of this. Okay. So let me write the formula for modulation index. So we had something called as modulation index. So what does it modulation index was doing? So modulation index gives me the quality of modulation. If mu is greater, modulation index also, if modulation index is greater, that means modulation is good. And that is given by amplitude of modulated wave by amplitude of carrier wave. Okay, so this is called the modulation index. Okay, okay. So this is for waves. We use this formula for waves. But what if there is electricity? Because in microphone and laptop, electric signals are traveling, right? So what is the modulation index for electric waves? So then we can write modulation for electrical signals is equal to voltage maximum in that circuit minus voltage minimum divided by voltage maximum plus voltage minimum, or equivalent to energy of the wave maximum energy minus minimum energy divided by energy maximum minus, sorry, plus energy minimum. So what is happening? So this, for example, imagine I have a carrier wave of 30 megahertz, and the modulated wave has a frequency of 45 megahertz. Okay, so then what will be the modulation index? I can say that acha, modulation wave is 45 megahertz and it says 30 megahertz. So the modulation index is 1.5. I can write in this way. Okay. Or if I say that if I take a circuit in which the current is traveling, it has a higher voltage drop of 30 volts and the lowest voltage is 10 volt. In this particular circuit, if they tell you in this particular way, then you can tell that acha, the modulation index will be maximum voltage is 30, minimum voltage is 10 divided by maximum voltage is 30 and minimum voltage is 10. So it becomes how much? 1 by 2. 1 by 2. So in this particular way also, you can tell the what is the modulation index. Okay, cool, right? So that's for the whole chapter, guys. Okay, and thank you for being here for a very long time, so that we were able to complete this whole chapter very quickly. Okay, so and okay, so from tomorrow or from the next class we'll be starting wave optics. In 3 to 4 classes again the wave optics will be completed. In this chapter there are very minimum formulas and minimum problems, but more of a theory oriented chapter, right? Okay, so revise it. It's a very theory oriented chapter. Okay, study them, study well. Okay, cool then. So yeah, so I'll just I'll go through the slides. Okay, so we started from how the communication happened in the olden days, right? And how the communication evolved from point to point, and what is point to point communication. So one person is talking to other person is called as point to point communication. If one point is communicating to many people, it's called as broadcasting. Point to point, and this is broadcasting. Okay, bye everyone, take care. Okay, I'll be ending the class in a minute, but I'm just showing you the slides. Okay, Then we had different elements. So what's a transducer? How does a transducer work? What's the signal and how does the signal work? What are different kinds of signal? And what's the noise? So noise is some unwanted disturbance what we get, and it's called as noise, right? And we had transmitter, which gives out the signal, receiver, which receives the signal. Attenuation is weakening of signal, amplification is strengthening of signals, right? Yeah, repeater will usually increases the range. Yeah, so these are like a few things what we studied. You can go back to my video again if you don't understand any concept, or you can visit the notes also at any time. Cool then. Okay, bye everyone, take care, see you all. Bye Bhargav, bye Vishalas. Okay, bye Zoom guys. Am I clear here? So submit the NPS. Only after you submit NPS you can leave Zoom guys. Okay. Okay. So then ending the stream here. Okay.